Fresh Thinking by Snowden Not Hero, the podcast where we explore the science behind better resource estimation and unpack the technical concepts that support better mining decisions. I'm Melanie Bulley, and today I'm joined by Senzeni Matondi, Principal Consultant at Snowden Not Hero, based in our Bristol office in the UK. Today's topic is one that many resource geologists have encountered at some point in their careers. What happens when mineralisation doesn't respect clear geological boundaries? In some deposits, all contacts are obvious, but in others, mineralisation occurs as diffuse stockworks, scattered vein networks, or broad alteration halos, where the transition from ore to waste is gradual rather than distinct. Yeah. So how do you model something that doesn't have a clear boundary? That's exactly what we're discussing today. Let's start with a challenge. Why do some deposits become so difficult to wireframe?
Traditional wireframing works well when geology provides obvious context. For example, if you have a massive sulfide lens or a well-defined vein, but some mineral systems behave differently. Mineralization may occur as dense networks of stockwork veins, which are distributed through broad alteration zones like your porphyry, your copper porphyries, or skarn deposits. So the host geology remains relatively continuous, but the mineralization becomes much more diffuse. So instead of asking yourself, where is the geological boundary? You're asking, at what point does mineralization become economically continuous? That's a much harder question.
So the difficulty isn't in necessarily understanding the geology, it's defining a practical mining boundary.
Exactly. So the geology still provides the framework. However, geology alone often isn't sufficient for defining those boundaries.
Many operations still rely on manual wireframing. What are the limitations with that?
Well, with manual interpretation inevitably introduces subjectivity. So you can have two experienced geologists. They can interpret exactly the same drilling and produce slightly different wireframes. So neither interpretations is necessarily wrong, but they're different. So when mineralization becomes diffuse, small interpretations or the differences can translate into large differences in tons, grades, and ultimately the project value. So that's where statistical approaches become extremely valuable. They provide consistency, repeatability, and a methodology that can be objectively defended.
That brings us to conditional indicator Kriging, or CIK. What exactly is it?
Okay, so conditional indicator Kriging is a probability-based estimation technique. Instead of estimating grades directly, we first convert our assay values into binary indicators. So, for example, you might have samples, you select samples above a selected threshold and assign a value of 1. And then the samples below that threshold become 0. So we're no longer estimating grade in this instance. We're estimating the probability that a block belongs to the mineralized domain, 1. So the output is a continuous probability surface ranging anything between 0 and 1. So each block represents the likelihood that it exceeds the selected mineralization threshold. So that's a fundamentally different way of thinking about domaining.
Absolutely. Once the data have been converted into indicators, what happens next?
So the next step is variography. Even though we've transformed the grades into zeros and ones, those indicators still display spatial continuity. So we model that continuity using indicator variograms. And those variograms define your anisotropy, the search neighborhoods, and the estimation parameters. So the resulting CIK model isn't trying to estimate gold grade, if it's gold, just the mineral of interest. So it's estimating the probability that that mineralization continues from one location to another. So that makes it particularly powerful for deposits with gradual ore transitions.
Yeah. Eventually, though, mining requires a practical answer. Is the block ore or waste? How do we convert probability into a mining boundary?
Okay, so that's the probability, the most important step, that probability. So the probability model itself isn't the final answer. We need to determine which probability threshold best separates your ore from the waste. Rather than selecting that threshold arbitrarily, we evaluate multiple scenarios. One particularly useful approach is comparing the conditional indicator Kriging, your CIK results, against the nearest neighbor estimate. So, it's the nearest neighbor technique provides a relatively unsmoothed data-driven benchmark. So by comparing this tonnage and volume responsive with increasing distance from the informing samples, we can identify the probability threshold that closely honors the data while avoiding unnecessary smoothing. So in other words, the statistics help to determine where this ore boundary should be.
Something else I found interesting was the use of sample distance. Why is that important?
So not all estimated blocks have the same level of confidence. Some blocks are surrounded by closely spaced drilling. Others rely much more on distant samples. So your distance to sample measures allow us to evaluate how strong each estimate is supported by actual data. So they help distinguish between areas that are well informed and areas where estimation uncertainty is naturally higher. So that's valuable both for domaining and for understanding the model confidence.
Seems this isn't really just about conditional indicator Kriging.
No.
It's about making domaining more objective.
Absolutely. So your traditional wireframes often depend heavily on your geological interpretation. However, with CIK, it's introducing a quantitative evidence into that process. So instead of drawing boundaries purely by eye, or we're allowing geology and statistic to work together. So the geology defines the framework, the statistics they define the spatial continuity. So together they produce mineralized domains that are reproducible, transparent, and technically defensible. So that's particularly important when resource models become the basis for your investment decisions.
So if there's one key takeaway from today's discussion, is this: not every mineral deposit provides obvious ore boundaries. When mineralization becomes diffuse, statistical approaches such as conditional indicator Kriging provide an objective and reproducible method for defining mineralization domains. Rather than asking, where should I draw the wireframe? The better question becomes, what is the probability that this block belongs to the mineralized system?
That's right. Yeah.
By combining geological understanding with probability-based estimation, operations can build more robust resource models, reduce subjectivity, and improve confidence in subsequent grade estimation and mine planning. If you'd like to explore these concepts further, Snowden Opterial's Mineral Resource Estimation and Applied Geostatistics Professional Development courses examine practical applications of indicator methods, domaining strategies, estimation workflows, and uncertainty analysis using real-world mining examples. Senzeni, thanks for joining us today.
Thank you.
And thanks to everyone for listening. If you've enjoyed today's discussion, subscribe to Fresh Thinking by Snowden Opterial, leave us a review, and share the episode with your colleagues. And until next time, thanks for listening.